All right, so we are back again for another day, another learning. Um, yeah, it's gonna be exciting. Okay, let's see. Where is Neil? Neil, introduction, lecture. I hope this is going okay. Let me double check. Okay, live. All right, looks like we are live. Isn't is not is HD. Okay, live. All right, looks like we are live. Isn't is not is HD. Okay, live. All right, that's looks enough. Like oh, that nut was so easy to bust. Okay. Right.
In this section, we're going to carry on working our way down the OSI reference model, and we've now reached layer 3, so you'll learn about the network layer. We are going to cover the format of the You'll learn about
Okay, concerning why is it not playing?
about the different types of traffic we can have on our network. That's unicast, broadcast, and multicast. And you'll also learn about the subnet mask and about how it defines the boundary between our different subnets. About the different types of traffic we can have on our network. That's unicast, broadcast, and multicast. And you'll also learn about the subnet mask and about how it defines the boundary between our different subnets. About the different types of traffic we can have on our network. That's unicast.
Okay, I can see the videos in Udemy, but looks like OBS is not capturing that. Let me try. Let me try adding a display capture. Let me delete this. Okay.
Layer 3 of the OSI model, which
Okay, this one is still not working.
is the network layer.
Okay, how to troubleshoot this one then? Hmm,
The network layer
is it with just this browser or do I have any other browser? Okay, I know where the problem is. Okay, now should work. That's a nice wallpaper. What's this about? Me Gen AI. Infinite talk audio driven video generation for. Hmm.
Jolene, 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 I'm begging of you, please don't take my man.
That's nice. Okay, anyway, let's get to our udemy.com. Okay, just give me a few minutes, few seconds. Okay. Jolene, Jolene, Jolene. Now that song is stuck in my mind. Jolene, Jolene, Jolene. Don't take my mind, don't take my mind, don't take my mind. Dun, 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 dun. Okay, now we are in. I hope.
Is
Yeah, there you
responsible
go. You can
for
see it.
routing packets to their destination on the network. So this is why routers
So what
operate
is
at the network layer. And it's also responsible for quality of service as well. What quality of service is, you might have one particular type of traffic that requires a better level of service than another level of traffic. For example, if you're running voice or video over IP, it's sensitive to delay, so we're going to give it better quality service than something like email. IP, Internet Protocol, is the best known layer 3 protocol. IPv4 is the focus of this section. There's also IPv6 as well, which is the upgrade for IPv4. Later on throughout the course, we'll be talking about why we have IPv6 and also its actual usage today and how to configure it. IP is a connectionless protocol, so there's no acknowledgements at layer 3. You can still have reliable traffic by using TCP and its acknowledgements at layer 4 or by having it built into the upper layers. Other layer 3 protocols apart from IP include ICMP, which is the Internet Control Message Protocol, which is used for ping for troubleshooting, which we'll also be talking about later in the course, and also IPsec for secure encrypted communications. There are other protocols as well, but IP is the best known one, by far the most commonly used. That's what we're going to be talking about in this entire section. IP addressing is a logical addressing scheme which is implemented at layer 3. So the network designer uses IP addressing to partition the overall network into smaller subnetworks, or commonly called subnets. By having different subnets, it improves performance and security and makes troubleshooting easier. It improves performance because rather than having one big flat network, we divide it into smaller subnets and we can keep the traffic on the particular subnet that it needs to be on rather than going everywhere. So we get better performance that way. We also get better security by having this logical addressing as well. For example, let's say that we've got accounting servers. We can put them on one particular subnet, and that makes it really easy to control who's got access to those servers. Also, it makes troubleshooting easier as well, because by partitioning the network into smaller parts, if we have a problem, it's easy to see what part of the network the problem is on and concentrate there. So that's our layer 3 addressing, uses IP addresses. At layer 2, which we'll get to soon in the next section, we have MAC addresses if we're using Ethernet. IP addresses layer 3, MAC addresses layer 2. IP address is a logical addressing scheme. MAC addresses is just one big flat global addressing scheme. So you'll see this section is going to be a lot longer, more involved than when we get to MAC addresses, because there's a lot more work to do here. There's no logical separation at layer 2 of the OSI model. It's done here at layer 3 with our IP addressing. Okay, this is the first lecture in our layer 3 section. So as usual, we'll have a review of the OSI stack again. You're going to see this several times because it's important, and I really want to drill it into you about how networking works based on the OSI model. Again, we've got the 7 layers. Layer 7 is the application
Application
layer.
layer.
When a
Layer
sender is
6 is a presentation layer. Layer 5 is session layer. Layer 4 is network layer. No, transport layer. Layer 3 is a network. Layer 2 is a data link. Layer 1 is a physical.
going to send traffic, it composes the packet, it creates the layer 7 information first. That then gets encapsulated in the layer 6 presentation layer header, then encapsulated in the session layer header. Top 3 layers are our upper layers, mostly the concern of application developers. As networkers, we start getting really interested at layer 4. So the packet, we've got layer 765, it then gets encapsulated with the layer 4 header, and that will either be a TCP or a UDP header, and the port information will be on there. That then gets further encapsulated in the layer 3 header, which is the subject of this section. Main information in the layer 3 header is the IP address information, but you'll see coming up shortly the rest of the information that's also in the header. Our network infrastructure device that works at layer 3 is our routers. Then we carry on making the packet. We put on the layer 2 header, which is the data link header, on a local area network that will be using Ethernet, and will have the source and destination MAC address there. Our network devices that work at layer 2 are our switches. Finally, the packet will actually get put onto the physical wire, that's at the physical layer, and our hubs work at the physical layer. Not that we still have hubs, we'll talk about that a bit more later too. Okay, last slide in this lecture, we're going to take a look at the IP header. So at the top row that you see there.
Okay, he had. What we're gonna do is we are going to do the downloads. We can delete that. We can delete this one as well. CCNA Anki flashcards. Is this just one Anki flashcard? Oh, wow. Jolly. Import. Okay. Alright. Let's do this one quickly. 57 questions. I think we should be able to do it. That one is a bit small for you guys, is it? Okay. Let me try to make it bigger. Yeah, since we are remote into it, it's no use. So, you'll have to stick around for this one. Uh, what is the speed of an Ethernet connection? 100 gigabytes, 10 Mbps. Ethernet connection. It's only a 10 Mbps. That must be something wrong. Okay. Again. Oh, it's this section. It's 100 meter. 10 kilometer. No shit. In a fast Ethernet connection, a router receives data on which pin? Yeah, fucking, I have not studied that. I think 3 and 6. Yay! Yo. But still, I have to. In a fast Ethernet connection, a firewall receives data on which pin? 3 and 6. How many pairs of wires are used in 10 base T cable? 8 or 2 4 wires. You know what? I'm gonna fucking It's mixing my knowledge, man. Its seven-layer approach to data transmission divides the operation into specific related group of action at each layer. What does that mean? Encapsulation, OSI model, oh, okay. But it was hard, right? It was hard. That's application layer, it was good. Toggle marks, what does that mean? Easy. Presentation, easy. Physical, easy. Internet layer. Mm, network. Oh, shit, that was not easy. Fifth, that's a session layer. TCP, UDP, and ports. Okay, easy. That's data link, MAC address, switches operate on that one, the normal switch, not the advanced one. It's easy. For its transport layer. That's where the that's the transport layer. That's where the ports and UDP IP goes. Session is not in there. Session has a PDU units. It's called packets, correct? But number four, that's transport layer, UDP IP, UDP and ports, TCP, UDP and ports. Transport. I think that's the packets. Fuck, I forgot the name of the packets, PDU units, but still, that's a transport layer, TCP, UDP, and ports. Good. These are application layers. Okay. TCP/IP stacks. That's application. Good. Network. It's internet layer. Good. That's physical layers. Data link and physical layer are combined in TCP/IP stacks. Network S6, or you can just call physical layer as well. Transport is still transport. Good. It's a protocol stack that consists of multiple protocols, including TCP, transmission control protocols, and IP internet protocols. That's a new OSI mod. New OSI mod TCP/IP. TCP/IP. TCP/IP stacks. Good. Which OSI layer provides networks? Which OSI layer provides network services to application of the user? Network layer or internet layer? That's number three. Wow, applications to the user. Oh my god. That's embarrassing. Application layer. Network services to applications of the user. Which OSI layer provides network services to the application? Question is confusing as well. The OSI layer ensures that the information that is sent at the application layer of one system is readable by the application layer of another system. It's both TCP, IP, or OSI model. Application layer, of course. Oh, the second one, presentation layer. Sorry. Yeah, so presentation layer has to communicate with the application layer. So he makes sure everything is readable for application layer, that pitch. Oh, it was hard. I had to think. The OSI model, OSI layer establishes, manage, and terminate session. That automatically, that's the session layers. That's where the session hijacking for hackers comes in. Still, I would say hard, and I'll like to repeat it. Which OSI layer provides network services to application of the user? That's of course application layer. Good. Which OSI layer defines the specification needed for activating, maintaining, and deactivating the physical link between end devices? Physical layer, of course, layer 1. The OSI layer defines how data is formatted for transmission and how access to physical media is controlled. Data link. How do you say data, data, data link? The OSI model. Okay. The OSI data link layer defines how data is formatted for transmission and how access to physical media is controlled. Okay, so physical layer will transmit, but it will decide how it will transmit and how access to physical media is. Okay, it will format the data. It does formatting the data, and also it says how you should be able to access it. Okay, data link has some power. I would like I'd say hard. The OSI layer defines services to segment. The OSI layer defines services to segment, transfer, and resemble the data for individual communication between the end devices. This OSI layer defines services to segment, transfer. That's the session layer, of course. Oh, transport layer. It defines service to segment, transfer. Oh, that dumb. Resemble the data for individual communication between the end devices. Transport layer. I have to learn more about this transport layer, man. Okay, that was again. That three is internet layer or network layer. Yeah, that was easy. 7 layer approach to a data transmission divided by operation into a specific related group of action at each layer. Encapsulation and de-encapsulation. Thus, a layer provides connectivity and path selection between two host systems that may be located on geographical separated network. Host to host communication. Network layer. Oh my god, I'm a fucking dumb network layer. Provide connectivity and path selection between two host systems that may be located on a geographically separated network layer. As a layer defines services to segment, transfer, and resemble the data of individual communication between the end devices. Transport, let's say hard. The Cisco operating system used on a majority of the Cisco enterprise grade network devices. What is it, guys? What is it, guys? What is it, guys? What is it, guys? The Cisco operating system used on the majority of Cisco enterprise grade networks. iOS, iOS, internetworking operating system. Okay, anyway, internetworking operating system. A bit uncomfortable to sit. It's good. The 7-layer approach data transmission did how much? Oh my god, I have like 79 again. The 7-layer approach to data transmission divides the operation into a specific layer group of action at each layer. OSI model. Oh, good. Fuck now. The OSI layer provides connectivity and path selection between two host systems that may be located on a geographically separated network. So, transport layer, network layer. Fucking oh my god, fucking. I'm gonna punch this motherfucker. Mm, the OSI layers ensure that the information that is sent at the application layer of one system is readable by application layer of another system. Presentation layer. Fuck you. Yeah, good. The OSI layer established, manage, and transmit session layer. Easy. Which OSI layer defines the specification needed for activating, maintaining, and deactivating a physical link between in devices? Data link? Oh my god, this is so confusing. This is fucking confusing. It's taking my brain out, taking my brain out. Easy, easy. No, 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 it was hard. Fucking four. Transfer layer. OSI layer defines how data is formatted for transmission and how access to physical media is a data link layer. Data link. Okay, easy. Transport. It's still a transport. Easy. Easy. Application layer. Easy. Internet or network layer. Easy. Physical link. Physical layer. Network access layer. Okay. Let's try. You can enter a to access help. Question mark. Easy. Where is the iOS operating system image stored? That might be a question to ask. Where is it stored, guys? Where is this stored? Let's say this is stored in SSD, hard drive, flash. Okay, again. The SL layer defines services to segment, transfer, and resemble the data of individual communication between the Windows transfer. It is a protocol stack that consists of multiple protocols, including TCP, OSI model, TCP/IP model. Okay. Okay, someone need my help. I have to go for help.